We've learned how to multiply and divide radical expressions. Now let's look at how to add and subtract radical expressions. Let's first remember how we combine like terms when we're talking about variables. Remember that when you combine like terms, if two terms have the exact same variable factors, you can just add the coefficients, the constant factors. 2x plus 3x is 5x, or 5x minus 1x is 4x. Or 9x plus 11x minus 2x, when there's three terms, is 18x minus 2x, which is 16x. So if we know how to do that, that makes adding radicals and subtracting radicals pretty easy. We just have to make sure that when we try to add and subtract radical expressions, the two expressions have the exact same radicals. In other words, the radicand in both expressions has to be identical. And if it is, then we are allowed to add that constant factor out in front together, just like we did with like terms. So in this case, 2 root 7 plus 3 square root of 7 would equal 5 square root of 7. And that radicand stays the exact same. You don't add the 7 and 7 make it 14. It stays as 5 square root of 7. 5 root 7 minus 1 root 7 would be 4 square root of 7. Or letter C, which is very similar to the one we did with the variable, would now become 16 square root of 7 when you combine these radicals. Now, let's look at some common errors that students will make at this. Let's see some cans and cannots. So let's first consider these four scenarios. Are we allowed to simplify 3 plus x anymore by calling it 3x? And we know that the answer to that is no, because that would mean 3 times x. So that also means that 3 plus root 5 is not this. That is incorrect. So this cannot be simplified any further because they don't have like radicals. Now, to the right here, can 3x plus 4x be combined? Absolutely it can, to make it 7x, which means that you can also do this one below it. 3 root 5 plus 4 root 5 is 7 root 5. So as long as they have the same radical, we can add those constant factors out in front of the radicals. Now let's look at 3x plus 3y. Can this be added together? Can it become something like 6xy? And we know the answer to that is no, because these are not the exact same variables. Which means that for this second example, if I have square root of 3 and square root of 5, these cannot be added together because they're not like radicals. So in this case, this expression is already simplified. There's nothing more we can do to simplify that. Now, when we look at this last one, it's not adding or subtracting, but still let's look at it. I have 3x times 3y. So now it's back to multiplication. And we remember that when you do a problem like this, you just multiply the constants out in front and then multiply the variables together. Well, that means that if we're looking at a similar problem with radicals, we do a very similar principle. We multiply the 3's together to give us 9, and we multiply the radicals together to give us square root of 15. And I show you this multiplication problem to see that multiplication is slightly different in the way that you can perform operations with radicals than adding and subtracting. So you have to keep those rules separate. Now let's simplify a couple of expressions that include addition and subtraction. So letter A, 9 root 17 minus 3 root 17. These have the same radicals of square root of 17. So I can subtract 9 minus 3 and give me 6 square root of 17. Letter B, again, I have this exact same radical. And remember that if there's just a radical like square root of x, it's the same thing as 1 square root of x. So when we add these together, we get 8 square root of x. So those could both be combined. Now when we look at letter C, we can see that these two radicals cannot be combined right now. We cannot subtract at this point. But we also know that this expression is not simplified. When it says simplify, not only are we trying to do the operation like add or subtract, but we're also looking to see that none of our radicals have a perfect square factor in them. So square root of 18 can be simplified further. So 5 square root of 2 can't be simplified, but the square root of 18 is the same thing as the square root of 9 times the square root of 2. And that's important to realize because the square root of 9 is the same thing as the number 3. So let's go one step further. Now I have 5 square root of 2 minus 3 square root of 2. And after I simplified this radical, I now see that I actually can subtract these two radical expressions because they have the same radicals now, root 2 and root 2. So 5 minus 3 is 2 square root of 2. So sometimes you'll need to simplify a radical before you're able to add or subtract it. So now try these two problems on your own. Pause the video, try to do A and B, and once you've come up with an answer, resume the video to see if you got it correct. Okay, let's resume. At this point, hopefully you have answers for letter A and letter B. Let's check it. 7 square root of 50 minus 3 square root of 2. These cannot be subtracted, but square root of 50 can be simplified. So let's take some steps to do that. That's the same thing as 7 times the square root of 25 times the square root of 2. And I'll carry down the minus 3 square root of 2. And I know that the square root of 25 is the same thing as 5. So this is really the same thing as 7 times 5 times the square root of 2 minus 3 square root of 2. And 7 times 5 is the same as 35. So this is 35 times the square root of 2 minus 3 square root of 2. And so now I can subtract these two expressions, and I get 32 times the square root of 2. And that's simplified. Let's look at letter B. Once again, not all of these are the same radical expressions. Now, we do notice that we have 4 square root of 12 minus a square root of 12. We could subtract these right off the bat. So let's, if we want to do that, we could. The other way we could begin by simplifying this is by noting that the square root of 12, the square root of 27, and the square root of 12 again, all of these square roots could be simplified further because all of those have perfect square factors. But let's go back to where we were just looking at here. And since we have 4 square root of 2 minus 1, 4 square root of 12 minus 1 square root of 12, we can make that 3 square root of 12 plus the square root of 27. So now that looks a bit more simplified. And now let's try and simplify each one of those radical expressions. So this is 3 times the square root of 4 times the square root of 3 when we factor out the square root of 12 there. Plus the square root of 27 is the same thing as the square root of 9 times the square root of 3. Now let's do this all in one step. The square root of 4 is the same thing as 2. So I get 3 times 2, which is 6, times the square root of 3. Plus, and then the square root of 9 is the same thing as the number 3 times the square root of 3. And now I have like radicals. I add them together and get 9 times the square root of 3.